Hello students, so welcome back to another session. We were continuing electromagnetic induction. So Faraday's law, Lenz's law, and the basics of alternating current, that is the coil moving in magnetic field. These three topics we have seen. So today we are going to see motional EMF. Okay, motional EMF is the EMF induced across ends of a conductor due to its motion. Okay, so the EMF induced across ends of a conductor due to its motion in a magnetic field is called motional EMF. Say for example, suppose if we have a magnetic field, like this. Okay, now in this, suppose if you have a conductor like this, okay, length L, okay, and if it is moving, okay, in some direction, okay, suppose magnetic field is going inside, this is L vector, fine, we will make this conductor to move in this direction with a velocity v. So in this case there will be EMF in this conductor. So for that also we can use right hand palm rule. We will get into deep discussion, but even now in the beginning itself I am just telling you the direction of EMF. EMF means how do we represent electromotive force? We used to represent like this. Okay, so now in this, suppose if this is the magnetic field direction, correct? No, magnetic field is inside. Now this is L. So if we consider the length as a vector, and if we consider this as the direction of length, then this is the direction of magnetic field, and this is the direction of movement, that is, this is the direction of movement, velocity, magnetic field. So where this palm is showing, place the positive terminal there, that is, here I can place the positive terminal. So this will be the direction of current. Okay, I repeat once again, this is the magnetic field, this is the direction of the conductor, then my palm is showing upwards. So in the uppermost side we can place the positive terminal. So that is how the direction of EMF. Okay, so remaining things we will see, even using Lenz's law also we will be able to say. Okay, that is, suppose again, now you might be thinking current will be in which direction? Obviously current will be in this direction. Nothing wrong in marking this, so both are same, correct? So if you are experts in Lenz's law, right? You are experts in Lenz's law. Suppose if this is coming, this conductor is coming out, then once if it comes out, going out of the loop, we can say that cross magnetic field is increasing here. In this loop, inside this area, if it is moving, then this also will come inside. Cross magnetic field is increasing. Cross magnetic field is increasing means we should make what? Dot magnetic field in order to decrease it. So what will be the direction of dot magnetic field? This one. Then this will be the direction of current, anti-clockwise, same thing here. Okay, clear? So we will discuss that again, no worries. So motional EMF is the EMF that is that will happen across a conductor when it is moving in a magnetic field. Okay, so this is the introduction about the topic. Now we will derive how to find this motional EMF. Okay, okay, now see children, this conductor, see, you can see the direction of velocity, this conductor, okay, this is also a conductor. On the top of it we have kept a rod, just like this. Okay, this is a conductor, this is a frame. Okay, someone took the frame and kept here. Okay, a conductor is kept. Now suppose if we are able to send current here, now this is a closed path, right? This is a closed path. Okay. For current to pass, we need not weld here. For current to pass through this, is it necessary that if we keep just on the top of the frame, how current will flow? Is it a closed circuit? Do you have any thought like that? Should we do a welding here for current to pass? Just if you have that doubt, go and touch somewhere in the plug. Okay, no welding is required. Immediate feeling and understanding we will get. Okay, right. So if we keep a conductor like this, definitely this will become a closed circuit. Okay, so if you may have doubts, no, that is why I said that also. Right, now come back to this. Now this conductor is moving with velocity v. So we could say that now suppose if this is the position of the conductor, this is the position of the conductor. Now what is changing here? What is changing here? Okay, magnetic field is constant. Okay, B is constant. We don't change the magnetic field. Okay, we don't change the magnetic field. So for EMF to induce, what should happen? There should be change in flux. Okay, there should be change in flux, or we can say that d phi by dt should happen. What is phi? Phi is B dot A or BA cos theta. What is theta? Theta is the angle between area vector and magnetic field. Suppose magnetic field is going inside in this case, and this frame's area either I can consider in this direction or this direction. I am considering, suppose if this is magnetic field vector. Okay, why unnecessary confusion? We will take the area inside. Okay, so if we take like that, then theta is equal to 0, and finally we can say that phi is equal to BA. Phi is equal to BA. Right. So induced EMF E is equal to what? D by dt of what? BA. Okay. Now when this road, if it is moving in this direction, say for example in dt time it has moved this much distance. In dt time it has moved this much distance. This length is what? Constant. This length is constant, correct or what? This length is constant, but this x is varying. X is varying. So in dt time, if dx distance is covered, I could say that this magnetic field is constant. B is equal to d by dt of what is area? Area is nothing but length into breadth. So in dt time, this much area is covered. This much area is covered, and the distance covered, say for example dx distance is covered in dt time. So this much area is covered in dt time. So what is the area? Area is nothing but length into breadth. So dx into this length is the breadth. Any confusion? Clear or what? Okay, and this length is constant. So I am going to take this one outside. Now this is going to be dx by dt. Okay, so dx length. Okay, suppose if we consider x length, let us consider this as x length is covered. So then it can be like this. Fine. So what is dx by dt? Dx by dt is velocity. Dx by dt is velocity. So EMF is equal to what? BLV. So this is what is the motional EMF, the formula for motional EMF. And when it is coming in this direction, okay, cross magnetic field will be increasing. We need to increase dot magnetic field. For dot magnetic field we should send clockwise current, anti-clockwise current. So this should be the direction of current. So what we will be getting? We will be getting EMF with what polarity? EMF will be this polarity. Clear? Understood or what? Okay, clear? Done? Okay children, so motional EMF E is equal to BLV. Motional EMF E is equal to BLV. There is a condition for this. Okay. For us to get motional EMF, a value for motional EMF, okay, non-zero value if we need to get, there is one more condition. This L, B and V, they must be mutually perpendicular. They must be mutually perpendicular. They must be mutually perpendicular. Just say for example, if this is L, okay, and if this is V, then we could say that this must be B. Suppose if this is x-axis, this is y-axis, this is z-axis, or we could say I, J, K. Okay, the vectors L, V, B must be in which direction? Suppose if this is L, then this must be V, and this must be what? V, velocity, like this. Clear or what? They must be mutually perpendicular. All must be in 90 degree. Okay, so that is one condition. Okay, otherwise it will give zero value. So remember this must be mutually perpendicular. Okay, so L must be perpendicular to B, okay, and B must be perpendicular to V. Okay, so they must be mutually perpendicular. Clear or what? And okay, direction. Regarding direction, okay, already just I mentioned again. Regarding direction, right hand palm rule. Right hand palm rule. Right hand palm rule. Okay children, so always fingers, all this is always in the magnetic field direction. Okay, so fingers, okay, magnetic field direction. This one, thumb, give the direction, thumb in the direction of motion or velocity. We can say velocity or motion. Okay, then whatever direction this palm will be showing, whatever direction this palm will be showing, that will be the positive terminal. Okay, in this direction on the top, okay, not near to it. Suppose if the palm direction is showing like this, mark the positive terminal like this. Okay, so positive terminal should come like that. Clear? Okay, so we will do a simple question. We will do a simple question. Okay, take down. So, okay, so this is the circuit. This is the circuit. Okay, just like this, and we are keeping a rod like this. Okay, this is 5 ohm. Okay, so this is 5 ohm, and this rod is moving with the velocity V is equal to 5 meter per second. Okay, so question is I in 5 ohm resistor. I in 5 ohm resistor. Okay, this is R, this is S, this is P, and this is Q. Okay, so options are there: 0.1 ampere, R to S along with the direction. Okay, then 0.1 ampere, S to R, then 1 ampere, R to S, finally 1 ampere, Yes, to R. Come on. Okay, easy. Okay, just an illustration problem. Okay, easy problem, no worries. What is the answer? Okay, EM of E is equal to BLR. Already you got, right? Pause the screen and do yourself. I'm sorry, I forgot to give the magnetic field. Okay, so magnetic field is also there. Okay, so magnitude of magnetic field is given as 0.4 Tesla. B is equal to 0.4 Tesla. Come on, pause the screen and do yourself. Pause the screen and do yourself. Okay, so motional EMF E is equal to BLV 0.4 into, okay, length, yes, I forgot, sorry, 25 centimeter. Okay, length is also given 25 centimeter. Clear? So 25 centimeter length is also given. E is equal to BLV. I'm sorry. Okay, so 0.4 into 25 into 10 raised to minus 2 into velocity is given as 5. Alright, so this is actually 100. This value is 10, and this is going to be how much? 4 into 25 is 100. This is 500. So okay, so EMF we will be getting how much? 110, 50. So 50 into 10 raised to minus 2, or we could say 500 millivolt. Okay, 500 millivolt. This is also fine. Okay, all right, correct. Okay, now we need to find the current. What is the value of current? What is the value of current? So I is equal to E by R. So E is what? 500 into 10 raised to minus 3 divided by what? 5. So this is 100. So we will be getting what? 0.1 ampere. 0.1 ampere. Okay, fine, correct. So two options are there, 0.1 ampere, 0.1 ampere. So direction we need to see. Direction we need to see. So right hand palm rule. Right hand palm rule. This is the direction of magnetic field. Direction of thumb is the direction of motion. So this will be the direction of what? Terminal, positive terminal. So obviously if we keep the positive terminal like this, current will be flowing in this direction. So R to S. Yes. Clear or what? Fine. Okay, children, comfortable? So I summarize. Motional EMF is BLV. One condition is there: direction of magnetic field, length and motion of the conductor, everything must be mutually perpendicular. Okay, then only the BLV answer what we are getting will be valid, or otherwise the answer is going to be 0. Why it is coming we will see now. Then direction of EMF or direction of current can be found by right hand palm rule. This fingers the direction of magnetic field, this thumb is the direction of motion. So keep it like that. Then where this palm is showing, in that direction, okay, the final terminal, first terminal should be negative, then next terminal should be positive, either upwards or downwards. Clear? Hope this is clear for you. Okay. Okay, children. So every time this need not be mutually perpendicular. Every time this need not be mutually perpendicular. I said when it is not mutually perpendicular, the answer will be 0. That answer will be 0 if any of the two vectors, okay, or any of the magnetic field, length vector, velocity vector, any of them is parallel. Okay, I am adding a condition there. Any of them are parallel, then it will be 0. Otherwise we will be getting some other value also. Okay, so directly using E is equal to BLV is valid only if B, L and V are mutually perpendicular. Okay, if they are at some other angle, what will happen, that we will deal it now. Okay, so motional EMF, next heading, motional EMF. Okay, when magnetic field vector, velocity vector and length vector are not mutually perpendicular. Okay, so in this situation, how we need to deal the thing? Say for example, suppose if this is the direction of magnetic field, if this is the direction of magnetic field, and if I consider a conductor, okay, if I consider a conductor like this, if I consider a conductor like this, and which is moving in this direction, so this is actually L, okay, this is L, okay, and this conductor is an angle which is having an angle theta, and this angle is alpha. This is not 90 degree, this is an angle alpha. So the length of the conductor is L, Suppose if we consider the direction of length, either this direction or this direction, no problem. This is the direction of magnetic field. So the length vector and magnetic field vector, okay, if they are at theta, and velocity and this length vector, they are at angle alpha. So everything is different, not 90 degree. Okay, so children, we have studied in moving charges and magnetism. If a rod is there, a current carrying conductor, if we keep in magnetic field, what will happen? It will experience a force. Even a charge with uniform velocity, if a charge is moving with a uniform velocity, it will experience a force. A charge at rest will not experience any force if we keep it in magnetic field. If a charge is at rest, if we keep in electric field, it will experience a force. A charge, if it is at rest in magnetic field, it will not experience a force. But if a charge is moving with velocity, it will experience magnetic force and obviously electric force also. So if in a current carrying conductor, definitely there will be what? There will be charge movement. So because of that, we have studied, if we keep a conductor, current carrying conductor, inside a magnetic field, what will happen? It will experience a force. Okay, now this particle, if this is a conductor, definitely this will have charges. So when it is moving with the velocity v, actually the charges inside the conductor is moving. So it will experience, these charges will experience magnetic force, and those charges will experience what? Electric force also. Okay, electrostatic force also. So this will continue like this. This will continue like this till it reaches equilibrium. It will continue like this till it reaches equilibrium. Equilibrium means what? The electric force will be equal to the magnetic force. Correct or what? Electric force will be equal to magnetic force. So this should be equal. This should be equal and opposite. Correct or what? Electric force must be equal and opposite to magnetic force. So electric force, if I write QE, electric force, if I write QE, this is equal to, I could write the magnetic force as V cross B. Okay, Q into V cross B, the force experienced by a charge in magnetic field. Okay, so considering all the charged particles, QV will be experienced by the charged particles, QV will be the force experienced by the charged particles. So we could say that E is equal to minus of V cross B. Okay, the electric field will be equal to minus of V cross B. And what is the potential difference and electric field relation, which we have studied in electrostatic potential and capacitance. Okay, in electrostatic potential and capacitance, we have studied the relation between electric field and potential difference. Okay, difference in potential. So dV is equal to minus of E dot dl. Remember, dV is equal to minus of E dot dl. So sometimes this can be E dot dx or E dot this E dot dr will come. Okay, E dot dr means for various directions x, y, z. Okay, already we have studied. Clear or what? Okay, so this dV, if we consider here, we can have E dot dx also we have done. Okay, so the potential difference is equal to minus of E dot dl. Already we have seen. So this is for a small difference. This is for a small difference. So the potential difference between, this is the potential difference between small difference between small distance dl. Suppose if it is for a large distance, then delta V is equal to integral what? dV, or we could say that minus, okay, integral E dot dl. Okay, clear? This is the potential difference. Okay, clear? Why we are moving to potential difference? Because then the potential difference between 2 points, okay, will give us to find the EMF that is produced between the 2 points of the conductor. Clear or what? So whatever we get here, okay, V cross B, if we substitute there, we'll be getting the answer. So delta V is equal to minus of integral here V cross B, okay, then what? Dot dl. Okay, velocity constant, magnetic field is also constant. So this delta V is equal to, here there was a negative here, this negative, okay, it will come here, so that will become positive. I could write V cross B, okay, and integral, these are constant, I took it outside, integral of dl. So integral of dl vector dot, okay, dot. So yes, so this is also vector. Okay, so if we integrate that length one by one, it is nothing but the total length. So finally we will be getting delta V is equal to V cross B, okay, here dot is there, okay, V cross B integrating this dl, we will be getting length vector. So this is the formula for finding the potential difference or EMF. Clear? Clear or what? Delta V we will replace, name it as EMF. So delta V is nothing but the potential difference between 2 points of this length, this conductor. Okay, clear? I repeat, this is the magnetic field, this is a conductor, the conductor is at an angle theta with the magnetic field, and this is moving at an angle alpha, this is moving at an angle alpha, then clear or what? At an alpha velocity, and this conductor, this is moving at an angle alpha. So if this is the case, then how to find the motional EMF? So this will move until it reaches what? Equilibrium. Correct? Same thing will happen until it reaches equilibrium. While equilibrium is what? Same and equal forces. So QE is equal to minus Q into V cross B. So we got electric field. So small change in potential is what? E dot dl. Okay. So the potential difference between two ends we can find by integrating this dV. Okay. So substituting the value of E, the value of, okay children, so the motional EMF, okay, the motional EMF E is equal to V cross B, V vector cross B vector dot L vector. Okay, so here this is called the scalar triple product, scalar triple product. Okay, so we need to first find the cross product of velocity vector and magnetic field vector, and whatever we are getting from this, that will be a vector, no, obviously this is cross product, that vector dot this vector, if we do, we will be getting the correct answer. This is always true, okay, whether it is mutually perpendicular or not, this is always true. And this length is displacement length. This length is displacement length. Suppose if a conductor, if is kept like this, okay, then we need not take this length, okay, which length we need to take? This length we need to take. Okay, clear? So this length, displacement length, is what we need to consider for this. Clear? Done? Understood? Right, and right hand palm rule, you know how to take the direction. Clear? Fine. Now we will do some simple problems for understanding the concept. So find the magnitude, find the magnitude and the direction. Find the magnitude and direction. Okay, so number 1, this is the direction of magnetic field. This is the direction of magnetic field. We kept a conductor like this, we kept a conductor like this, L, and this is moving with the velocity V. So just like a VBL, okay, or BLV, whatever be the magnitude you are getting, please write your answer. Okay, so pause the screen. Okay, not like the previous problem, I have given every data. Okay, so pause the screen and please do this answer. Okay, answer in terms of formula, just BLV means BLV, fine. Okay, done? Clear? Okay, so our formula is V cross B, okay, dot L. Okay, so what is V cross B? What is V cross B? V, magnitude of V, magnitude of B into what? Sin theta. So this is what is this term, and dot L vector. Okay, so V is moving in this direction, magnetic field is in this direction. What is the angle between velocity vector and magnetic field vector? That here only we have to put that. So velocity is also in this direction, magnetic field is also in this direction, so theta is what? 0. So this is going to be what? Sin 0. So the entire thing will become 0. Clear or what? So this formula, if we apply, we will be getting the answers correctly. Okay, if we study only BLV, what you are going to do? They will give 0.4 Tesla, this is 2 meter per second, this is 1 meter. Very easy question. This time Neet was very easy. I will be scoring very good marks. With this impression, we will come out. We will be at peace, okay, nimmadi, till the results come. So tricks will be there. Tricks will be there. That is what. Okay, children. Okay, everything will come well. So what I am trying to tell is tricks will be there. Clear or what? So this is the actual formula. Okay, shall we do the next problem? Done? Clear? So do yourself, children. Okay, please do yourself. Please do yourself. Okay, and verify the answer. Right, so next one is, again, this is the direction of magnetic field, and we have, this is length of the conductor. This time we will change. This is the direction of velocity. Now tell me, what is the magnitude of EMF? What is the magnitude of EMF we got? Okay, done? Okay, pause the screen and do. Done, right? Okay, clear. So EMF E is equal to V vector cross B vector dot L vector. Clear? So this is the direction of velocity. Fine, good. Direction of velocity and magnitude of velocity, magnitude of magnetic field. Okay, this one. So here sine theta dot L vector. Good. So VB, what is the angle here? Magnetic field and velocity is 90 degree, right? So sine 90, and whatever we are getting through this dot L vector. Okay, so this is VB, we get, and this will be a vector, right? This will be a vector. What will be its direction? How to find the direction of V cross B? This first term V, already we have seen. Second term B. So curl your fingers from V to B, where the finger is showing. Okay, finger is showing inwards. So let us consider inward as just like this is I, this is J, if it is K, that is Z, X, Y. So if we take like that, what direction will be getting? V cross B means inside it is going. Let us put K. Correct or what? Fine. What is the direction of L then? What is the direction of L? Let us put unit vector for L also. This is the power of what? Vectors. L is what? Either you can take plus J or minus J. Let us take plus J. So LJ. What is the dot product of K dot J or J dot K? 0. Correct or what? 0. So the answer for this is 0. Clear? So seems to be easy question. Okay, tricky. Answer is 0. Clear or what? Fine. So the point is, the final note is, if any two vectors out of this VLB, velocity vector, length vector, magnetic field vector, any two vectors are parallel, answer will be 0. So write the note: if any two vectors in B vector, V vector, L vector are parallel, okay, then EMF will be 0. Clear? Done? Okay, good children. Okay, so shall we do the third question, another question? Okay, done. So let us do our third question. Okay, okay, done. So third one. Okay, again, right, so this is the direction of magnetic field, and this is the conductor. Okay, this is moving upwards. Okay, sorry, velocity. Okay, velocity, and this is the length. Okay, length. So what will be the answer? So here the length vector is parallel to B. Either in this direction we take, either in that direction if we take, whatever it may be. Okay, so fine, definitely this answer is going to be what? 0 from the note itself. From the previous note what we have written, without wasting time you will be able to answer this question. But we will see. E is equal to V cross B. E is equal to V cross B dot L vector, right? So V upwards, B this direction. So this is the direction of V cross B. Definitely it is going inside. So VB, their angle is what? 90 degrees. So sine theta will become 1. So it is going inside. So I am going to put K. So dot, what is the direction of L? Li. So definitely this is going to give 0. Okay, K dot I is 0. If you are not comfortable in this, what we can do? Just put to VJ and cross be I, just like that you can put the unit vectors and dot Li. If you want, you can do like this. Again, you will be getting the answer as 0. But if you are comfortable without writing, you will be able to do this. Clear or what? Okay, children? Done? Shall we do next question? Okay, right. So the fourth one is, okay, so this is the direction of magnetic field. Magnetic field is going inside. Magnetic field is going inside. Okay, clear? So now a conductor which is moving in this direction V, and this is length L. Okay, so what will be the EMF? What will be the EMF? Okay, so E is equal to V cross B dot L. So magnetic field is inside, velocity is going in this direction. So this is going inside, this is going in this direction. So this is 90 degree. So VB. So this is the direction of velocity. So we cannot curl like this. No? So keep it like that. This is the direction of magnetic field. So we need to, V cross B means take the direction of V. If this is the direction of V, magnetic field inside means we will have to curl like this. No, just keep it like this. So curl. This will be the direction of what? V cross B. So V cross B will be getting J dot L. So what is L? L is I. If we take I, so what will be? We will be getting, definitely we will be getting some answer. Okay, so sorry, V cross B will be J. Okay, V cross B will be J, and yeah, sorry, L is what? J. L is this side, so J. So what? B LV will be getting. This is the EMF. Correct. What will be the direction of current in this conductor? Either this direction or this direction. How to find the direction of current? What will be the direction of current? So this is B. B is going inside. Direction of velocity is this. Okay, so this will be the direction of what? Positive terminal. So let us consider this is the direction of current. So it will come like this one. Okay, so direction of current will be this. Clear? Clear or what? Fine. Shall we do one more problem? Okay. Okay. See children, in vector basics we have seen, if we get a cross product, if we do a cross product V cross B, the direction of resultant will be perpendicular to V and perpendicular to B also. Suppose if we do A cross B, we are getting C. So the C will be perpendicular to A and C will be perpendicular to B. This is a fundamental of what? Cross product. We have studied this. Okay, we are all human beings, lot of works, lot of studies, so we tend to forget. So just a quick recap. Okay, right. So here V cross B. So when we do V cross B, whatever result we are getting, so this result will be perpendicular to V and that result will be perpendicular to B also. Okay, so please keep this in mind. Okay, done? Fine. Okay children, so take your another question. So suppose, okay, question number 5 of this category. So this is the direction of magnetic field. Okay, so this is the direction of magnetic field. So a conductor, okay, which is moving in this direction, at an angle 30 degree, and its length is L. This is the direction of B, This is the direction of velocity, this is length. Okay, so what is the induced EMF? Okay, what is the induced EMF? Question is, what is the induced EMF? Okay, so options are BVL by 2 root 3 BVL by 2. Option D is 2 BVL. Yeah, so pause the screen and do yourself. Okay, pause the screen and do yourself. Clear? Okay, shall I try to do? Okay, so again, E is equal to V cross B, okay, dot L vector. Okay, so what is V cross B, children? What is the angle between velocity and magnetic field? What is the angle between velocity and magnetic field? If this is the direction of magnetic field, whether I go in this direction or this direction or this, whatever I do, the angle will be what? 90 degree. So velocity V is moving in this direction, but magnetic field is what? In this direction. So whether I move in this direction or this direction or this, whatever it may be, the angle is what? 90 degree. Okay, magnetic field is this, velocity is moving like this, 90 degree. So E is equal to VB sine 90 dot L vector. Okay, so E is equal to VB, we will be getting magnitude. What will be the direction of this VB? Direction of VB will be, that is the direction of resultant. Direction of result of V cross B will be definitely perpendicular to V, will be perpendicular to B also. Okay, so suppose V cross B na, so this is the direction of B. So if when we curl like this in the direction of magnetic field, where the finger is going, this thumb is going, this is the direction of what? Velocity. I am curling the finger like this, where this thumb is going. Thumb is going in this direction. So I could say that the resultant of V cross B is going in this direction. So suppose resultant of V cross B, okay, if we name it as R, what should we name? Okay, resultant of VB, okay, result of VB, we will name it as R. So this resultant of VB is perpendicular to V, and obviously it is perpendicular to B also, because B is going inside, this one is going in this direction. Clear or what? Fine. So this is in this direction. Now this one dot L vector. So now this angle is different. Now we will have to apply the angle, right? So this resultant RVB L cos theta, A dot B is AB cos theta, right? So what is the angle between this resultant and this length? That is what we need to substitute here, not this 30 degree. Immediately when there is a 30 degree, we will have a temptation to throw. So if we put here 30 degree, cos 30, okay, so this RVB we will put as VB itself. Okay, directly we will be getting the answer. So VB, okay, so this VB is a vector. Okay, so VB is a vector. Okay, so VB L cos theta. So immediately if we put here cos 30, if we put cos 30, what answer we will be getting? Root 3 by 2. Yes, here it is. That is wrong answer. Definitely you will be getting negative mark. We will feel okay, it was easy. No. So the thing is, the angle is nothing but, suppose if this is 90 degree, this, what about this resultant, that is VB vector makes with this L. This VB vector makes with this L, that angle is what we need to choose. That is nothing but 60 degree. This total is 120 degree. So this is 60 degree. So the answer is VBL cos 60. Cos 60 is what? 1 by 2. So VBL by 2. This is the answer. This is the answer. Clear? Some of you may ask, sir, why can't I take this one 120? No problem, you can take. If you take that, no worries, nothing will go wrong. That will become cos 120. Cos 120, what you will do? Cos 90 plus 30 you will do. So that will become sin 30. Again 1 by 2 will come. Anyway, definitely we are not going to choose the direction of current or EMF from this. Direction of current we will do our right hand palm rule or Lenz's law. Clear or what? Now, what will be the direction of EMF? That how we will find that? Direction of magnetic field is going inside. This will be the direction of what? Velocity. So palm is showing in this direction. Palm is showing in this direction. So direction of current, palm is showing in this direction, means we will have to keep the plus here, minus here. Plus and minus will be kept on the conductor. So what will be coming? In this way. So current will be flowing in this direction. In this direction if we are getting, it means that we can tilt like this. Okay. So keeping EMF in the circuit doesn't have angle and all, right? Direction is there but doesn't have angle and all. So we can take like that. Okay children. So right. Okay, fine. Okay, so that's all about motional EMF. That's all about motional EMF means today's session. Okay, next session we will continue from this. We will do varieties of problems and we will deal it. Okay children, so hope you understood the session. Thank you so much. Keep studying. Good luck. Goodbye.